This is a problem right here. It's the sum of 3 consecutive integers is 81. Find the 3 numbers. Do you ever wonder why? What's the purpose? Well, today we're going to learn how to link it to make it purposeful for you. Okay, but before we even begin, I want you to attempt this problem. Any way you want to attempt it. Take a couple of minutes, write it on your paper, try to figure it out, and we're going to see if we have different approaches to answering this question. Before we begin, I want you to take a really close look at this word right here, consecutive. What does the word consecutive mean? What does it mean to you? And give me an example if that's the way it's easier for you to explain.
Like one after the other.
One after the other. Okay, so give me an example of 3 consecutive numbers.
1, 2, 3.
1, 2, 3. Okay. One after the other. 1, 2, 3. Are those the only consecutive numbers that exist?
No.
No. Infinite consecutive numbers. Now give me an example, Chrisnell, of non-consecutive numbers.
Let's say 7, 9, 10.
7, 9, and 10. They're not consecutive. Maybe these two are,
But not 7 and 9.
but not 7 and 9, okay? Okay, let's look at one more word in this lesson. Sum. Hector, what does sum mean to you?
It's the addition when you put them together.
When you put them together. Fantastic. So it basically means addition when you put them together. Okay, so now let's read the sentence. Chris, can you read that sentence for me again? See if it makes a little more sense.
The sum of 3 consecutive integers is 81. Find the 3 numbers.
Okay, Annabella.
Yeah.
We're finding 3 numbers that are what?
That are next to each other.
Next to each other. And Daniela, whose sum is what?
81.
81. Okay, now attempt the problem. We have a clear understanding, I believe, is that they needed to know how to read that word problem and break it up into pieces. I did notice when I was walking around and they were solving the first problem that there were many different strategies to arrive at the correct answer.
I did it the harder way. I kept adding 3 numbers until I got something that equal to 1, and I realized it was 20.
But you still got it, and it's very interesting because that's the way it makes sense in your mind. How many of you would have taken her approach?
I took it.
You took it. Did anybody take it algebraically?
No.
Nobody. Interesting. Okay. Some students just used, as one student had said before, common sense. And they just use a division operation to be able to solve it. When another group solved it algebraically using variables. And another group solved it in their own way, but were able to justify how they got the answer. So, my main focus, my lesson objective, was to teach them how to translate words into algebraic expressions. So one group had a very clear understanding of how to do that. So I went ahead and worked off them. I brought the students up to the board and allowed them the opportunity, though, to explain their methods. I wanted to show them that there is definitely many different ways to answer a problem and for them to share their perspective on the problem. The ways you got these problems, believe it or not, every single group did it a little different. Okay, so I'm going to start over here. Please pick somebody to represent your group and come on up to show me. All right, Chris, now it's you.
I got the answer because it's saying numbers, so I use a variable. It's n plus 1 plus n plus 2.
You guys decided to use a variable. You chose n as your variable. Can you choose any letter?
Yeah.
You could. Can you use a capital letter? Yeah? You can use whatever letter you want? Okay. Sounds good. Sounds good. Now, that group over there, pick a representative, please. All right, Chris, come on up.
Simple way.
3 different methods, 3 different strategies, we still got the same number. Now, I'm going to focus on the algebraic way, because today we're going to learn how to translate words into algebraic expressions. You did a fantastic job, though. Okay? Now, I want you to look here. If we're talking about 3 consecutive integers, sometimes it would be great to split up those integers. Maybe say number 1, number 2, number 3. Do you think that's a good method? Do you like that? Do you like listing it? No. No? You don't? Okay. So how about we just then, by looking at this problem, how about we kind of break them up? Do you like that?
Yeah.
Okay, so we'll say this is the first one, first integer. Why would the second integer be n plus 1?
It's a consecutive number.
It's a consecutive
So
number.
it's the number you did plus
Plus
1.
another. So it could be consecutive.
Right, plus 1. So it's the number you did plus 1. Great. So this would be the second consecutive integer. Okay. So you can clearly say 1, 2, and what's the third one? And why is it n plus 2?
The first number you use plus 2 after 2 consecutive numbers.
That's right. Plus 1 is the second number. Plus 2 is the third number. Okay. What do you notice that's in between those sets of numbers? What do you notice, Chelsea?
That they're adding them together.
They're adding them together. And why did you choose to add and not subtract or multiply or divide? It's easier. What key word in the problem gave you to show that method?
It's positive.
Okay, positive. Nice. And then we want to come up with the same total, a total, the sum, that equals 81. Now, I like the way, Chrisnell, that you combine the ends. Okay? It was almost like, here's one, here's the other, here's the other. How many ends do you have together? 3. There it is. 1, 2, 3. She put little loops to represent it. And then she combined the constants, 1 and 2. What's 1 plus 2? 3. Good. And then we solve an equation like we normally do. And then, of course, divide by 3. She got 26. 26 represents which one of these? And. Good. 27? So 26 plus 1. Can I actually substitute this number in to check my answer?
Yeah.
Yeah. So 28 plus 2. Am I right by saying that?
No, it's 26 plus 2.
That's right. You caught me. It's 26 plus 2. I can't say 28 plus 2 to check it because n, this is the original. N plus 1, n plus 2. See that? Okay, do you have any questions? All right, it's your turn. I'm going to give you a worksheet. And what I'd like you to do is to identify problem number 2 and attempt it. And then we will group together to share and discuss the strategy you chose and share your answer. Let's see if you got the correct answer.
But if we have 8 of carbon, that means that we have they would have 26 minus 8, that will be 26, 18. 18 of hydrogen and 8 of carbon. But it doesn't make sense with the first rule that you gave us.
You don't think so? I think so, according to what you're telling me here. Because there you go, Daniela, you put it right back. 18 plus 8 equals 26.
But then it says that we need to have 6 fewer hydrogen atoms and 3 times the number of carbons.
31.
And you wrote it there.
All right, hold on.
I subtracted
8
18
times
minus
3,
26.
is 24 minus 6.
Even though I divided by negative 6 and
You got it.
that's what
I was looking at it the wrong way.
the answer was right there except for divided.
Okay. There it is.
So it's 8 yet.
There it is. And title, what is 8? Which one? Hydrogen? Carbon? Decide. Make a decision.
And hydrogen is 18.
And why? Why did you say that? Why is carbon 8 and hydrogen's 18? Which one made you decide? Tell me.
Oh, because when you multiply 8, which is carbon, times 3, you get 24.
Okay.
And that's 6 more than 18, which is the hydrogen atoms.
So you made sense of it.
Yeah. And 18 plus 8 is 26 atoms.
Sounds
So we need to
great.
split it now.
All right, so we're going to come back. Let's regroup. I love the way you guys are really including your strategies that we spoke about when we did the consecutive integers. And you're trying really hard to understand the problem. And that's the first step to being able to solve any problems algebraically. I'm going to ask for one representative of the entire class that absolutely knows that this problem makes sense to come up here and present it. You're absolutely sure. You know you want to. You know it. Come on up, Hector. And show us your strategy.
Okay. So the problem will tell us that propane is made up of 26 atoms. So we need to have in total 26. And then we know that propane is made up of hydrogen plus carbon. That's what we need to get. So they're asking us how many atoms of each does it contain. And they're telling us that hydrogen is, and you subtract 6 from it and it's 18. Which is equal to the hydrogens you needed to have. So that's the answer.
Okay, very nice job. Remember the strategies that we spoke about. All your strategies were great, so let's try to implement them in the next 3 problems. You have approximately 10 minutes to do this. Okay, the variable right here, tell me which ones have like terms. He's saying it's the one that has the same variables.
Okay.
Which ones have like terms?
The 2, right?
The 2K and what else?
And the K minus 3.
Why'd you come up with 3? Tell me why it's 3.
I put it's over here, so imaginary 1, and I plus 2 is 3.
Good job.
And,
Imaginary 1.
And then I put 79. Subtract 4, give me 75, and then I
You divide by 3.
divide by 3, give me 25, and
And then you get the 79 and subtracted by 25, and you get the 54.
How'd you get 54?
Because out of getting 25, which is Kyoko's age, then you subtract it from 79, which is the total age that we need to get, and we get 54.
That's interesting. My main focus, my lesson objective, was to teach them how to translate words into algebraic expressions. I've given you the opportunity to look at the problem, and now again we're going to get our bodies in motion, and I'm going to change the groups around just a little bit again. If I can please have Claudia, Yosbel, Danielle, and Ernesto come sit over here, please. Okay. Now, I'm going to give each of you a specific job, each of the groups a specific job on this one geometry problem that involves algebraic expressions. Okay, so I would like this group, using problem number 1, to focus on identifying the variables. If you want to take notes, to write that down so you know what your goal is. I want you to identify the variables and give a value for the variable. So identify the variables, give a value for the variables. You're going to work in a second in your cooperative groups solving your task. That's your task, your goal. This group with problem number 1, you're going to focus on putting their variables into an equation. So as soon as you are ready, you're going to send over a representative. In the meantime, you come up with an idea, but you have to go with the variables that they suggest. Okay? But come up with the idea together. And then this group, again, you have a task. Your task is to solve whatever equation they came up with. Okay? But in the meantime, because we still have to wait for the variables to be identified, the equation to be put together, and you guys to solve it, what I'd like you to do is kind of come up with your own strategy and discuss with each other on what strategy you would take. But you're still going to use their equation. Based on previous assessments and the informal assessments I was doing as I walked around the classroom, I noticed that I wanted to group the students into different groups. And at that moment in time, I was able to get one problem, one word problem, and I separated the levels of learners into different groups. I had one group focus on just identifying the variables. And then based on the information they found and identifying the variables, they communicated that with the second group. The second group was responsible for putting the format of the equation together. Once they put that equation together where it would make sense, they would take it to the third group, where the third group was a little more advanced group that they can go ahead and solve the equation and bring it back to the word problem to see if it did make sense. Tell me what equation you came up with. And then, if I can have, please, one representative from this group. How about Daniela? You come show me what you did with the equation that Group 2 provided you with. Oh, no, not solving it, just identifying. Tell me what your group decided to do. Just identify. Okay?
Remember?
Okay. The longest leg is 2L.
Okay.
The shortest leg is L.
L. And this one
And
is?
the remaining leg is N plus 2.
Put L plus 2.
Okay.
Okay, good. All right, so go ahead, please, and share it with the class. My strategy, first I had students select because I wanted the students to be engaged in learning. I wanted them to participate. But then, while I was doing informal assessments walking around, I wanted to pick on the students to come up to the board. First, I wanted one that would know how to clearly explain the problem to the students. But then I also wanted to pick a student that perhaps had a little bit of learning difficulty understanding the lesson, so that way they could be assisted by maybe the peer that was standing next to them, or they could even call up their partner to the board to assist them. And then I wanted to pick somebody that had an aha moment. I saw somebody really struggling when I was doing informal assessments. Then all of a sudden, they got placed on that board, and they knew exactly what they were saying. They were able to clearly communicate with the rest of the students what the problem was asking and communicate that effectively with the students to solve it.